Bingo. The left-hand side was proved by the assumption. The right-hand side was not. This is our remaining proof obligation. How do we prove this? Skip. Right, there's an n at the head of both sides. So apply, perm, skip. Okay. Now what? This looks a lot like the induction hypothesis. Now we have to prove this. How do we prove this? Let's clear everything except H0. How do we prove this? There's a lemma. Let's search for a lemma that involves permutation and length. Ooh, this is a good one. Permutation length. So let's apply permutation length in H0. Okay, that's nice, but it's not exactly what we want. But let's simplify in H0. So this is almost what we want. How do we get what we want? Inversion, exactly. So we inversion on H0, and it's already done the rewrite, so we're done. Okay, so selection sort, no. We haven't yet proved that selection sort is a permutation. We've proved that cell sort is a permutation, but proving that selection sort is a permutation is easy. Let's prove this. What does it say? That if we select the smallest element from x cons AL, and that's y, then y is less than or equal to x. Well, no, not quite. It also has to be true that y is less than or equal to every element in BL. Okay? So, how are we going to prove this? This actually, as I said, requires thinking. But I think we could do something like this. Y is less than or equal to every element in y cons BL. That seems true enough. Y is less than or equal to y. Y is less than or equal to everything in BL. So that's going to be easy to prove. We prove it by saying constructor, because remember, for all is an inductive proposition on the structure of this thing. And if we just say constructor, we'll get that for all cons. And now we have to prove this. But that's provable by auto. And the other thing is provable by auto because it's exactly what's above the line. All right, so we've got H1. Now, we're going to use for all perm on this guy. So what's a permutation of y cons BL? Well, x cons AL is a permutation of y cons BL. So let's look at assert H2 colon equals select perm. And it says, let's instantiate x and L with x and AL. So select perm of x AL is this fact. And if we rewrite by H0 in that fact, we get this. Okay. So now we can apply, well, assert for all, H3 colon equals for all perm yeah, well, there's an implicit argument of for all perm. So it says this, for all A, F, AL, BL, etc. And I just do this assert in this way because I can't remember exactly how for all perm goes, and it's convenient to just put it above the line like that so I can see what to do with it. And what to do with it is instantiate it with what? Well, the A type is going to be nat, and the F is going to be this function, and the AL is going to be